Hi, it's Gadget UK here again. This time I want to add a fan on top of the VIC chip here. These heatsinks probably need swapping out because, you know, I've got the same sort of types paired up there, and then this one, I think I only had two of the larger ones and one of the smaller ones. To be honest, I prefer the larger ones in this one because it gets very, 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 very hot to the point where you put your finger on it, you can't actually touch it. It really does get that hot even with the heatsinks on. So I was going to put one of these little miniature 12 volt DC fans. They come with like an adhesive thing, so I mean I could sort of stick that on with adhesive. There are some screw mounts there, as you can see, there's three. I guess I could probably get, this might be a bit difficult to get the screw through because of the blades and things, but I could get a screw through into there as well, you know, into one of the actual grooves of the heatsink, and that's probably what I'll do. I'll probably use a bit of tape and then stick one screw to hold it in as well, just to make sure it doesn't come off. And I've got the thermometer here, we'll measure it, I'll measure it you know, beforehand and then afterhand. But the other thing that I wanted to try and do was put some temperature control in there so that it's not on all the time, but actually it might need to be on all the time. It's one of those, the simplest solution actually is to just leave the fan on top of there all the time, probably. But I wanted to test one of these little boards out anyway, because you can see they're quite small, and it's the sort of thing that if I can get the right standoffs to go under here, maybe some plastic ones or sticky feet. I think I've got some sticky feet actually that might just fit through there. Could actually just easily mount it there. But the question is with this is whether it saves the settings after power off. You know, you can predetermine, you know, configure sort of the range there, what temperature setting using this little probe that comes off here, which would need to be mounted. I might need to move these heat sinks, perhaps pull them off and then just wedge it between them or something. Like that somewhere. But yeah, so the point I'm trying to make is you can choose the temperature setting using the little screen there, and it's whether it saves it. I think it may well do from reading the instructions. There's only a couple of quid this, so it's a good test because you could maybe use this in other places as well, but it will just fit quite nicely on that position there on the board internally. So provided it saves the settings, that would be really useful. But it's just a question of whether there's any point or not. In something like a floppy drive, when perhaps you don't want the fan on all the time, it might be a good idea. In here, it might just be easier just to leave the thing running all the time, because you really want the VIC chip to be as cool as possible and not really get a chance to even reach a predetermined temperature, if that makes sense. And it may well be that, you know, using this, it may well, depending on how effective the fan is, it may well be that it comes on, it goes off, it comes on, it goes off. It could actually start becoming annoying, do you know what I mean? I could just imagine if every 10 seconds it comes on for 5 or 10 seconds and then goes off for 5 or 10 seconds again. It could be quite annoying if you can hear it. I guess it depends how silent it is. But before I do anything, I'm just going to tap off a couple of wires here. And one thing I discovered, I should have seen this actually when I looked at this particular board before. It might be the same as some of the other revisions, but the 12 volt regulator's here, and you've got this track that comes down to a pad there, so that's like a 12 volt test point, and the one over here is a 5 volt test point. I've tested that with continuity to the 5 volt regulator of the 7805 over there. So and they've got ground there, so what I can easily do is just attach a wire to ground, a wire to 12 volts, and then feed them into here, and then wire up the fan. I think you've got 12 volts goes in there, your ground, and these are the two contacts from the relay. Well, what I will do is probably join a link over to one of the inputs there. The other connection is going to go to the plus of the fan, and then the fan ground is going to go into here as well, and then that should work. So we'll give that a try, see how I get to see what happens really, I think. So you can see I've just taped the sensor there. I've got my plus 12 and my ground coming into this board here. Got my link going across. I will connect the fan in a minute, but if I switch this on now, you can hear it click there, and it says 31.1. This has got up to 31.1 degrees, I think. So if I just switch it off, what I need to do is just lower the value there, I think. So we'll put it on when it comes on at 40 maybe. Let's just try and do that. Press that button, I think. 30, yeah, you see it's set to 30, so that's probably not very visible on the screen. So we'll increase that to maybe 35, let's try that. 35. There we go, it's gone off. So I'll switch it off, switch it back on. So remember the setting, the relay didn't click. As soon as that gets up to 35, we should hear a click. And if we use this thing, we'll see it's a similar. I get 33, I think. You can see that 33. It's a few degrees different than what this is showing. I believe this actually. I think this is more accurate. But as soon as that gets to 35, I might need to edit this. We should hear a click. But you can see the temperature ramping up there. 32.5, 32.6. I can't see the damn screen now. 30.8. Any second. There you go. So the fan would now come on. So I think, having tested that, and if I switch it back off, yeah, I feel that, yeah, that's pretty hot. And like I said, I've put the thermometer on there. Hopefully you'll be able to see, yeah, 34.5, 0.3, 0.1, it's going down. But you can see it's not far off. You know, the value I'm getting on the screen here is pretty similar to that. That's not bad, that, for about £2.50 I think this was shipped, which is pretty good. It's a nice small compact board, and it remembers the setting after you switched it off, which is really nice. So I can embed this within here, just to leave it, and I think that's what I'm going to do. It probably doesn't need it, but I'll have a play around with it and see if I can get the ideal sort of setting and stuff, so the fan's not on all the time, and we'll see how effective it is. The worst case is I could always just pull it out and just leave the fan in 24, you know, so it's on all the time. But if I just strip the ends of these wires off now, and I can just stick them into the two contacts here, and we can give it a go. While I'm on the note of these fans, actually, it's always worth checking with your meter. Put your meter on diode test mode, and just test from, put your plus on the negative and your negative on the positive, and just make sure you get a diode reading. In fact, I'll just do that now. If I just put the meter there so you can see, and hopefully there you go. Can you see we get a diode reading there, 0.582. That shows there's a diode across the fan. You know, if you imagine your DC line coming in at the top, then you've got your fan, and then you've got your negative output. The diode goes from the negative side of the fan, from anode, but it's cathode going to the positive. And it's kind of, I think, I forget the exact term for it. They call it, you know, it's also classed as a flyback diode as well. You get it in flyback circuits, and it's just that when the fan, when you imagine you switch your power off, your fan's going round, right? You switch your power off, your fan keeps going, and you get some charge going back the other way. I think you get some like negative charge going back up onto the, you know, instead of it being powered, it ends up powering while it's still rotating. And the last thing you want is that on your 12 volt line, because you could kill something. It's not likely, but it's always worth just checking you have that diode there. Most cheap fans usually do, but some of the like really older fans, if you get a really old fan, you may well find it doesn't have that protection diode there. So anyway, we'll yeah, strip the wires off that, give that a try. So here we go. Here's a quick test now. It's just loosely sort of sat on this plastic here to isolate it. As soon as it gets to 35, hopefully the fan should come on. So we're approaching 35 degrees now. It's on 34.4, and it just hold this. I'm not sure whether it's going to stay attached, whether the torque of the fan is going to cause the problems with the wires. Soon find out. Any second. Interesting thing straight away there, I can hear a humming on the screen from the TV. So there's some noise or something getting from that. Well, you know, the fan there interfering with the TV. I might need a cap on that or something. We'll have a look at that in a minute. But you can see the fan going around there. It's quite effective, and the temperature's dropping there quite nicely. 33.2. Might stick around that. It's gone off now. 32. So it's holding it quite nicely. That's quite a nice little, elegant, discreet little circuit going on right there. I think you can change the lower limit as well. Maybe I've got the lower limit set to 32 or 33. Maybe I've got it set quite low, but that's just going to go back up to 35 now. So the fan has not been on that long. It's not off that long. It's quite silent. I can't hear that. I'm tempted to lower that setting actually to about 30 and just keep it really cool most of the time rather than let it ramp back up to 35 degrees. It's going to come back on now any second. There we go. And can you hear that noise from the TV? That's like a little buzzing noise, so it does need the cap. We've got some noise, you know, on the 12 volt line there. It's probably going straight to the SID. So yeah, not too happy about that. Don't really want any issues with the SID as a result of this, but we'll see if we can filter that out. Maybe stick an electrolytic on it or something, that might just do the trick. So this is what I've decided to go with here. This is a slightly different diameter fan. It's 40mm as opposed to 45, so it's a little bit smaller. This is said 45, actually they look about the same, don't they? It's a bit bigger, slightly bigger. Here's the original board. I'm not going to use this because I've tested this actually. From cold it was about 24, 25 degrees, and as you can see it's just a bit lower than that now. It's actually cooler than it was ambient. It was actually 25, so yeah, the fact it's just below the temperature it started at is actually good. And I've gone for this approach rather than using the temperature control module here, because constant changes, from hot to cold, that's what causes the problems with failures, if you like, heat-related failures anyway. It's the temperature variations there that, from cold to start, switching off and on, that could, stress some of the components on the die and stress the die itself out, connections to the die, etc. It's temperature, fluctuations there cause, fatigue issues, effectively, from what I understand. Ray Carlson touched on this actually, and it got me thinking. I read an article that Ray Carlson put about fans, saying it's a good idea to stick a fan on there for that very reason. And it was just when I started thinking about the practicalities of, if you use a temperature control module like this and you set it to say 30 or 40 degrees, then drop it to maybe 20 or 30, that 10 degree or even 2 or 3 degree variation on a frequent basis as it switches the fan off and on to keep it at a certain temperature could actually aggravate problems. So I think it's better just to have it constantly cool, as cool as it can possibly be, right from the offset, so that the die never gets a chance to warp very much, if you like, the connections and the components and things, and they don't get a chance to heat up so much that they degrade their connectivity, if you like, that you get any sort of stress or fracture type thing going on any of the connections and things inside. So I think I wouldn't know what effect that has at a microscopic level on the actual gates and things themselves. It probably has the same sort of support, the fact that you keep it nice and cool all the time. It's probably going to last a lot longer. But something like this, I would say, is highly applicable maybe in a disk drive, where you don't really want the fan running all the time. You just don't want the drive to get to a very high temperature, critical, so you could say, I don't know, you could test a floppy drive, it's 1541 or something, determine that after half an hour or 40 minutes it gets up to 50 degrees, it starts at 20 to 22, creeps up to 50. You may well stick a threshold on this, a setting, configure it so that at 50 degrees it comes on, it goes back down to, I don't know, 30 or 20 or something. But even then, you're still potentially causing the thing I'm trying to avoid with this, really, by stressing the die by having temperature variations there due to using this. But I'm sure there's plenty of places to use this. I'll use this somewhere. I just don't think it's best suited in this C64. And that's just, I don't know that I showed previously, but this fan was making a whining noise all the time. So I'm not sure why. It's going to be something to do with the way the fan is constructed, the actual circuitry stuff in there. There is a flyback diode on it, or a snubber diode I think it's called, but it was still doing it. This one isn't. If I turn the volume up quite loud, you can hear switch it off and on. You get a noise when you switch it off. Just listen to this, that little sort of yeah. I have actually experimented and just put a diode across there, another snubber diode, just to I mean, I've measured it and it measures like there's a diode, but I put a diode across there anyway just to double check. Still does it. So I'd be interested to know from any sort of experienced electronic engineers out there, why is that? Why do you get that reversed sound? Am I putting the SID at risk by doing this? Because that is one thought I've had with this, that ultimately the idea of adding a fan here, you could end up setting yourself up for a fall with your VIC and your SID based on the fact it's running off the 12 volt line. Now I did get some of the 12 volt regulators. I did consider having a separate dedicated 12 volt line for this. Is that recommended? I'd be interested to know people's thoughts and experiences there. Maybe running a fan off the supply that SID and VIC are using might not be a good idea. There could be issues with that. So yeah, I'm open to some discussion there just to see what people think. I'd hate to, in 6 months' time I've killed my SID because, powering off and powering on, you can hear that there's no noise, it's just silent. absolutely silent. The volume's very loud on the TV. So the fan was the issue with that sort of feedback noise, if you like. This seems like a much better fan. This is one, I forget what this is for. This one's like just a dedicated GPU fan. In fact, that one is as well, actually. It came with a heatsink, but as you can see, I've not got it screwed onto the heatsink at the moment. But yeah, I'm pleased with that. It's going to be constantly cold now. I think the other thing worth pointing out with this is, and there were a few things that led me down the road of considering putting a fan on here. At the same time I was messing around with this, it was quite warm weather actually, and I did some tests and I took the lid off, and I just just out of interest, I thought, I want to see how hot the Vic chip is getting, and I put my finger on top of the Vic chip and it was so hot I couldn't touch it. Now it's interesting the fact that I mentioned that actually on somebody else's video. I think it was one of Stig's World's videos, or it could have been Bawak, one of his videos, I can't quite remember, but I mentioned it on there, and someone said, "Oh yes, I think it was Bawak actually said it's the ambient room temperature is going to make a difference. If you in a room, say, which I'm here conservatively, it's like 30 degrees or something, and you start your C64 up, you're starting at 30 degrees probably, somewhere around that. It might be a degree or two less because it's in the shade, but you start, your overall ambient temperature is higher to start with, and you can end up running hotter as a result, which is an interesting thing. And I guess that's why in warm weather PCs and things are more susceptible to fail. It's the same thing. It kind of makes sense if you've got a certain ambient temperature to start with. Whatever your start temperature is, you're going to go higher than you would if you were in a cooler environment. So that was the first thing there. Sorry, I lost my thought train there for a minute. The other thing that got me looking at adding a fan onto this was on one or two occasions at least since I got this C64, I found that it would switch. You switch it on, and you get a black screen, and I'd be like, "Oh God, what's wrong? Something's failed." But my suspicion was the Vic chip, because I know that when I pressed the Vic chip down originally, when I put the heat sinks on, that was when I got that same problem. Now I did take the Vic chip out, clean all the legs up, clean up the socket, etc. I think ultimately it's because this chip gets so very hot, because on this particular revision, there's no heatsink. You can see the shielding's missing from around here. Normally I'd have a heatsink with a prong or something that sits on it. Because it's never been heat sunk, if you like, I think there's some degradation in the connectivity between the socket and the chip itself. So after I cleaned it up and reseated it, it was fine. But then having pushed the heat sinks down, suddenly it wasn't working again. Now there's nothing wrong with the actual solder points on the chip itself, there's nothing wrong with the chip. It really is a fatigue thing. Again, I think it's a thermal fatigue thing over time, where the pins and the socket edge have kind of just got a bit too hot at some point, and maybe tarnished in some way, got some oxidization or something. So I cleaned that all up again, but ultimately this is why I visited this to stick a fan on. It's not just the fact it's getting ridiculously hot, that heat is actually translating into potential connectivity issues between the chip and the socket, despite the fact there's nothing really wrong with either of them. I could probably at some point maybe consider swapping out the socket, and that's probably going to improve things, but it's very rare for that to be a problem now, since I cleaned up the pins on it. But that is also a common thing with these. Sometimes you can get black screen C64, think there's a problem, even take the Vic chip out, put it back in, still doesn't work, and actually you have got some oxidization there, especially on this particular revision where it has not been heat sunk. So you can see the final touches here now. It's not that elegant really. I've used a bit of heat shrink just over the top of these components. They could be better laid out. These wires could be shorter here because they're quite long, but yeah, I'm not that bothered. They're not going to go anywhere. They're not going to go under the fan. This works really well now. I've managed to get rid of any of the sort of interference from the fan. The previous fan, I tried right at the start of the video there, was very, very noisy. This one is pretty silent, and I don't just mean physically, I mean like in terms of the electrical noise it's generating on the ground line. I suspect, I'm not even suspect, I know you should have a separate ground line really for something like this. But I've managed to get around it, the tiny little bit of noise that this fan is generating on the 12 volt line. I've just used, I'll just show you, just like a general purpose diode, like a 1N4 4001 or something like that. I think that's what I've used, from the 12 volt line into the 12 volt line of the fan. So there's I think the first component there's like a diode going, it's providing the 12 volts to the fan, and then in series with that I've got one of these little beads, these little ferrite beads that just help take off any high frequency noise or anything that's generated on there. And then on the return path to the ground I've just got another one of these little beads again, and after trying that there's just nothing. There's just nothing at all. No noise. There's nothing. There's no visible effects on the display there. There was with the previous fan. The previous fan would change the colour, sort of the hue or the saturation a little bit or something. It's a bit weird. I think it's because maybe the the ground being affected there was something to do with it. It's like a bias thing or something going on somewhere when it's first switching on. I've got no idea. But having added let's say the diode there coming from the 12 volts in through a bead, and then the return path going through a bead, there is nothing. There's no noise at all. Might still not be safe practice, so anybody more experienced at electronics out there, let me know what you think. I've read all sorts of things about separating ground planes. I'm not sure how you would do that on this, unless you've got a completely separate supply. Your supply, I think, ultimately is the only way you can separate your ground lines. So, we've got a common ground line in here. We've got plus 12 and plus 5. That's it. I did think earlier on about sticking a second 12 volt regulator in here. Now that'd be fine for separating noise from the plus 12 volt line, but I don't think that's the case. I think it's always been about the ground. But then again, that diode, when I added the diode to the 12 volt line there, that made a huge difference, despite the fact this has got a snubber diode across it already. So don't know, I'm out of my depth again with this, but I think that'll work. Just I'd be interested to just know what people's opinions. Is there a bit of risk in having this on here? Bear in mind, it has got a snubber diode in there, and I've got a diode to protect, to stop anything, any reverse voltage going back onto the 12 volt line. It's just this ground. It's the shared ground thing with having a fan, because they do generate noise, and somehow it gets back onto the ground plane. So as you can see, switch back on now. Switch it off. No noise, whereas before you'd go sort of noise as it powered down. It's nothing. You hear a tiny little bit of a hum when it first switches on. But yeah, I think that's going to be because I've got a common ground plane, and I shouldn't have really. But it's not affecting the picture or anything like that. It's exactly the same with or without the fan. But yeah, it's it generates an awful lot of coolant. That's definitely the best solution. And using that little temperature controlled module I showed earlier, it's probably not the best idea, because you want it as cool as possible, really. In retrospect, I'm sure I'll be able to use that little board somewhere else, because it was quite a cool little board there. But I'm just not sure this is the best place to use it. Anyway, thanks for watching. I'll see you soon.